So in the previous videos, I have explained you how we are going to use the lump capacitance model. What are the requirements for lump capacitance model, which is defined using the Biot number. And in this video, we'll be go ahead and solve some questions or examples for you. How do we apply it and how do we check on how do we use the concept of Biot number and how do we check if the system or my mass or my building can be used as a lump capacitance or not. So let's start with the very simple single object, which is a gypsum board. And I hope you understand what the gypsum board is. It's a kind of POP, plaster of Paris. So gypsum is the technical name of the material which is used in the plaster of Paris. And let's say we have a characteristic length of the gypsum board as 0.5 inch. The surface resistance given as 0.68 hour degree Fahrenheit feet square upon BTU, and my R gypsum, which is the material conductivity resistance, and it is given as 0.45 hour degree Fahrenheit feet square upon BTU. So first of all, the most important thing is to convert and get the units, required units. So this heat surface resistance is analogous to our H value, and this surface material conductivity resistance or material resistance is analogous to my K. So we need to convert these things to the required. So using this, my K value becomes L by R, and hence this is 0.5 upon my resistance is 0.45, and this will be, and I need to convert the things to inch from inch to feet. So I also need to multiply this by 1 feet by 12 inches, and my value becomes 0.09259 BTU per hour degree Fahrenheit feet. So remember, the K, the conductivity, has a feet only in the denominator, while the H, which we are calculating now, will be 1 upon 0.68, and the value comes out to be 1.4706 BTU per hour degree Fahrenheit feet square. So remember, the Biot number, which is defined as HLC by K, eventually is a dimensionless number. So we want the dimensions of H, LC and K in such a way that it becomes dimensionless at the end. So now I can calculate BI, which is the Biot number, HLC by K, and we have the H values and all right now, and the value comes out to be 0.662, which is greater than 0.1. So remember, in the previous video I said that Biot number should be less than 0.1 for lump capacitance model. So if it comes out to be greater than 0.1, then the material or this board, which is having these characteristics, the length, the resistance values, or the heat transfer coefficients for H and K, having a Biot number is 0.662, so we cannot use lump capacitance model. I hope you have understood how I made the calculations and everything. Now let's go to concrete, because that is one of the second and most common part of our buildings. So let's take the second example of concrete. And for concrete, my structure of the concrete is such that I have a concrete slab which is 6 inch in length. My Ri resistance for upward, the values for resistance is for upward and downward will be different, because in natural circulation or natural heat transfers, for resistance towards the upward it would be lower, because when this surface gets heated up, the hot air will easily transfer to the upside of it, because hot air is lighter in weight, the density of hot air is lower, while it will not support. So over here we have supporting natural ventilation and buoyancy effect. Over here it will not be the case, it will be opposing it. So the resistance for upward will be less and it will be having a 0.61 value. For downwards it will be having a 0.92, and the units are same as what we have written over here. These are the resistance values, so units are constant. Now let's do the calculation. So obviously the LC, for your understanding, will be 3 inch. Why? If I make a calculation, let's say this is having a length and breadth. So my LC will be volume by surface area, length into breadth into thickness of 6, and my surface area will be length into breadth, and this is one of the surface from which the heat transfer is happening. The same is the upper surface also from which the heat transfer is happening. So 2 times length into breadth, and hence my LC becomes 3, and that's why I have written LC as 3 over there. Now my Biot number is H LC by K. For K we directly have the value of K. The resistance is given by 0.08. That's the resistance value for my concrete. But the H value is dependent on 2 factors now, which is Ri and Ri down, Ri up and Ri down. So there are 2 surfaces and these are in parallel. So hence my the reciprocals are added to get the resistance, and hence I have my H value like that. My LC is 3 inch, which will again be converted to feet, because we have them in inch, and others everything is in feet square, and this is in inch, and my K is 1 by R resistance, which is 0.08, and now my Biot number comes out to be 0.654, so which is still greater than 0.1, and hence I cannot use this structure as lumped capacitance. But let's go to the third and some more interesting, more practical application, where we have our concrete plus walls, and this is wall. This is one of the most accurate example I can take right now, and then as and when we develop more equations to solve for temperature and heat transfer, we'll have more and more accurate, where we'll also convert the air inside my building. But otherwise a building usually has walls and some concrete slabs. So what we have right now is we have the concrete, and to simplify, let's assume my walls are horizontal. So this is one of the wall on top of my concrete slab, and this is the another wall which is on the bottom of my concrete slab, and this is my concrete slab. And the properties of my concrete slab remains same. This is 6 inch and 0.08 as my resistance value, but my wall is R10 wall. I am introducing a new terminology to you right now. But R10 wall basically means that taking into account all the heat transfers which are possible from my concrete wall and all everything from the wall, which includes the conductivity, convectivity, everything, conduction, convection, radiation, everything. My R10 means the wall has a equivalent resistance of 10 and the units are the same. Units doesn't fit here, but the units are the same as what we have written over here. So this is the same unit and the value is 10. So R10 wall means that, and hence my Biot number is from both side my wall is going to have heat transfer. So my H value becomes 1 upon 10 into 3 inch into 1 feet by 12 inch. So this is my LC. This is my overall H value, which is given by resistance R10. So 1 by 10 into 3 upon K, which is 1 by 0.08. And now my Biot number comes out to be 0.024. And this is less than 0.1. So now we have successfully modeled my building very close and very accurately, which has concrete and wall, and my Biot number is 0.024, which is less than 0.1. So now we can use this model of concrete and wall, which is structured like this, concrete and walls are like this, and use this model as a lumped capacitance. So we can use multiple more equations which we'll be studying in upcoming videos, and also estimate the temperature of the wall or temperature of concrete or temperature of air inside my room using the equations. Thank you.